Hello everyone, welcome to my presentation on what plan? Virtual plan visualization with PDSim. My name is Emanuele de Pellegrin. I'm a PhD student in robotics and autonomous systems at the Edinburgh Centre for Robotics and Ottawa University. This presentation will cover the origin of the name of the paper What Plan, a question that introduced the plan visualization problem and why it's important. Next, will be presented how to achieve plan visualization or explanation through systems and projects already available to the planning community and how PDSim approached the problem differently. Finally, this year in KEPS, I want to present PDSim by giving a live feeling with a brief demo of the system and how it's easy to set up and simulate a planning problem with it. What plan? A basic question that a student asked me when I was helping with the AI course this year at my uni. We have an example here on the left about how a plan can be. Simple text representing the actions to reach the goal. This is a simple and trivial plan, but is it valid? What if the action sequence is bigger and we're trying to make a sense out of it, reflecting a reasonable and valid output? We need tools to validate and verify plans. Let me give an example. These two plans, still trivial, represent two solutions for the block's word problem. One is valid and the other is not. Most of you already spot the wrong one, but for non-expert users like students, it might be difficult to guess. In fact, if we visualize the output graphically, it might be easier to spot it quickly. The one on the right must have something wrong in the domain definition, as the plan has been generated regardless, but the simulation shows a cube floating in the air, not a complete stack, like on the left. Visualizing plans can therefore help in quickly spot or catch modeling errors. In this particular case, the error was introduced in the block's word action stack definition by simply removing the not before the effect clear y, representing the object that has been stacked. The correct version is this, with not. This might be a common error for non-expert user, simply missing a keyword in the model definition but still generating a plan that is unfortunately invalid. This brings us to the last point about why visualizing plans can be helpful, and inexperienced users are the focus. Helping in catching modeling errors using 3D or 2D graphics and animation might be a better approach rather than figuring out the plan and reading it line by line. Okay, but what can be done already if one wants to start visualizing and simulating plans? The planning problem visualization has been previously investigated. Here we have some systems that can help visualize a plan, like JEDI, a system that is designed to help visualizing plans for the robotics domain. Planimation, a tool developed in Unity to display 2D representation of PDDL and animate plan. LPS, a visualization system that runs inside the browser, and PDSim, a graphical interface to simulate AI systems, such as automated planning. And here we come to PDSim, which stands for Planning Domain Simulation, and how it tackles the problem of planning problem visualization and how it contributes to the former systems presented. PDSim is built within the Unity game engine. It makes use of its components such as the 3D or 2D rendering, the physics system, the path planning, the virtual effects, the audio system, etc. etc. These tools are already available in the engine instead of using the tool for game development purposes. PDSim used them to build a simulation environment. PDSim offers a language-agnostic tool to set up simulation, which is paramount for users that are not familiar with PDDL and Unity. Therefore, there is no need to learn an additional scripting language to create animations. PDSim offers a more abstract environment so the user can simulate problems on different types and complexity. In the example, a student has used PDSim as a simulator for planning robotics. And finally, PDSim let the user customize with no restrictions the objects and the agents inside the simulation. Now, how PDSim works? The user submits the domain and problem file through the Unity interface to get parsed. PDSim operates with a Python backend that runs the AI Plan for EU unified planning library that, conforming with the vision of PDSim, aims to simplify the adoption of automated planning as AI technology. UBF is part of the AI Plan for EU project. Here the PDDL files are parsed and the server sends back to the Unity the JSON representation of the planning problem to be interpreted by Unity. The user can set up models, animations using the built-in tools, and when simulating, a request for plan will be sent to the running server, and the plan, again JSON format, will be sent back. Let's have a quick example. Okay, how to create a new simulation in PDSim. This is the standard Unity interface when you first open a new project. When you import and drag and drop basically the Unity project inside Unity, you'll be presented with this folder structure when you have the materials, the model, the PDSim simulation that will be created, and the PDSim core scripts and file. To create a new simulation, we just go here, PDSim, new simulation, we type the simulation name, we select the domain and the problem file, and we hit create. PDSim will create a new scene for us. You can see here in the hierarchy we have the simulation name as the scene name, and with the game, and we have a starting plane, a starting simulation environment. Let me note that the server, the PDSim server, is already running in the background, and this is taking care of parsing the PDDL and sending back to Unity. Okay, let me open up now any simulation that are already here, and just for showing you how to animate objects inside PDSim. This can represent the logistics domain, where a van needs to reach a certain point to deliver a package, and I've used specifically these two models here, representing the van and the flag for the target. You can find the simulation object inside here, and we can test a simple animation. We open the graph and we present it with this window, and this is the entry node for our system, for our animation system, and we can animate either the positive fact or the negative fact. Basically, when PDDL is set not at a specific location, we are trying to animate the positive fact. So we can create animation nodes and transform and move object animation. We can simply select the van and put inside the object folder here, and we can connect the positive to the next animation. We want to get the goal, right? And we want to get the position of the actual flag here. So we can go here and type animation nodes getters and get object position, and we pass the flag red. So now the object position will be our goal, and let's try if it's working. Just press play. Yeah, and we can see the van is instantly teleported to the goal, but we can adjust this without coding. We can open the graph again and we set the animation time to be 1.5 seconds there, and we can see the animation again. Now it's smoother. Okay, so we can stack animations. For example, I created a particle system here, and let me show the example. And if I want to play after the track is moved, just nodes, effects, particle system. The previous animation is the object move. The final position, I want to play the particle system where the truck has arrived, and the particle system is this. And let's play. And it works. For future work, PDSim wants to support partial plans defined by the user, adding more simulation feature like following simulation actions, replaying previous actions, modify the simulation speed, or displaying partial animations. PDSim wants also to visualize the current state of the agent knowledge and beliefs to support, in the end, epic standard planning. This ends the presentation for PDSim. Thanks for your time and attention. Bye bye.